Hello, this video is going to show you how to compare delta y and dy. Delta y means the actual change in a function, and dy is the approximate change from the differential. So first let's start with delta y. That has nothing to do with calculus. It's just an easy algebra question. It's just the amount this function changes when it goes from x equals 2 to x equals 2.02, which is the change in x. So there is a formula for that if you want it. It's the value of the function at x plus delta x, meaning the value of the function after the change, minus the value of the function before the change, so just f of x without a delta x. So to calculate that, you would do f of 2 plus 0.01, and then minus f of 2. So you're going to plug these in. You're going to get 2 minus 2.01 to the fourth. And from that, you're going to subtract 2 minus 2 to the fourth. And I did that already. I got negative 0.32240.801. So that is meant to be done with a calculator. The approximate change, dy, which should approximate delta y, is going to be done without a calculator. This is just like the tangent line approximations. As a matter of fact, it is a tangent line approximation, but we're not finding values. We're just trying to find the change in the tangent line and compare it to the change of the original function when x changes this much. And I'll explain that more in a minute. But dy is f prime of x dx. That's the formula for a differential. So dy equals f prime of x, which is negative 4x cubed, times dx. Now dx is the change in x, and the change in x, the actual change and the actual change and the change we're going to use for the differential is the same thing. So delta x and dx are both 0.01. The x is where you start. So we're starting at 2 and then going through that change. So you would use 2 for x. And then just calculate this. And it's an easy calculation, as I said. 2 to the third is 8. Any order you want. I'll do 8 times a negative 4, which is a negative 32, times 0.01. That's easy. That's negative 0.32. So you can see that was easy to do without a calculator, and that's the point. And you can also see that it approximated the change very, very nicely. It's only off by 0.0024 and some change. So you would expect that to be a very close change because the change in x was very low. Now, just that we're done with this problem. I just wanted to show you the theory behind it. What we're doing, and this is not this graph, what we're really doing is this. If you look at a graph and say it's at 2, just like we're doing right here. So here's the graph. And at 2, you drew a tangent line, just like we did when we were doing the tangent line. And that's a horrible tangent line, but I just want to make a point here. Close to 2, the tangent line is hugging this graph. So if I go up to 2.01, the value of the function is right here. The value of the tangent line is right here. Now, delta y will just measure this distance from this point to this point, but the y distance. The tangent line dy will just measure the distance from that point to the point on the tangent line. So the theory behind it is these distances should be very similar because the tangent line really does not fall that far from the graph. Now, it's a horrible picture, sorry about that, but I want you to think back to using tangent lines to approximate values. All we did was figure out the values at each point and approximated them. The difference here is we're just trying to find the difference between one point to the next on a graph, and it's close to the difference from one point to the next on the tangent line. So that change in y is what we're calculating for these differentials. Hopefully that didn't confuse things. This is how you do it. If you have any questions, ask me next time you see me. So have fun doing the problems.